All right, great. Good morning, everybody. We're going to talk about skills, but of a different persuasion. So, there's my disclosures. Work in NVIDIA. I teach at Johns Hopkins and currently the chair of the planning committee for IHE Radiology. So as Dr. Koff said, I've been doing healthcare for 25 years. I started up in Ottawa at the Ottawa Cancer Centre, part of Cancer Care Ontario, and then Ottawa Hospital, and then Winchester District Memorial Hospital. And I've been doing a lot of work in imaging after that. I was at AGFA. I was co-chair of DICOM, working with 27 for DICOM Web. You can find me up on YouTube if you want to learn about IHE profiles. But today, I'm going to talk a little bit about agents. The world is changing. How we use computers is changing. How everyone will use computers is changing. And it's just watching, even in the last 2 months, the amount of change that's happening and how it's going to affect all of us. So I'm going to give you just kind of a passover, not too technical, but just to arm you with the knowledge of what to be thinking about for agents. As this transition happens, and as we think about what this all means to me as a clinician, as a user of computers, as an organization, either on the provider side or on the vendor side, I've done a lot of work in my career around standards. What does standards mean in this place? And then just kind of touch upon where do we go from here. So if you could walk away from this with that, I think that's going to be really, really important. Oops, other direction. I wanted to start out and just touch on other aspects of autonomy. If we look at self-driving cars, super fun, right? So we started out, when I first started driving, I had a K car. It had no automation. I had to control everything. Over time, we've seen improvements in a very iterative fashion. This chart helps us kind of score what are the capabilities of the vehicle I'm driving, whether it's helping me with cruise control or braking if I get too close to the vehicle in front of me, to doing things like lane control, to handling the common tasks of driving, and here I am as an operator all the way through to complete full automation. But as it turns out, it's kind of fun looking at this, even in the city of Hamilton, there are so many different permutations that a self-driving car would have to take care of. Things like bollards, which I don't even know if I'm pronouncing that word right, but and chevrons and all kinds of different things on the streets of Hamilton around some of the more interesting intersections. Cars driving into buildings, these kind of weird crosswalks and how cars get from one point to another. Even when I checked into my hotel, trying to get to the entrance was a little bit of a difficult thing. There are so many permutations, whether that's, just forget about what's happening on the street, but also cars and trucks on the street, pedestrians. When we think about, rain or snow, or it's nighttime, or there's animals on the road, there's so many different things that can happen. As we think about the capabilities of self-driving cars, at least to start, it's very narrow. We look at is there something in the way? Is there a stop sign? Is there a pedestrian? When we start to look at what do we need to take from here to get to the next level, we need to start applying some forms of reasoning. When I'm making lane changes on a highway, I need to be going at a certain speed. I need to be looking at all the cars around me. I need to make sure there are no other obstructions. All of this really comes down to, at the start, this idea of knobs and dials to set up how these integrations work. Even as, working in the hospital and building out dashboards, it's all knobs and dials. If I do stoplight charts and things, I have to think about what do I want to see and how do I put it there, but it's very brittle. It'll fall down very quickly. As soon as there's something kind of, non-standard to what I was expecting, the whole system breaks. And in a life and death safety system of a car, we can't have those kinds of things failing. So we need these kind of methodologies to frame how we're going to get to full autonomous driving. And so when we look at how this journey applies into medical imaging, again, we've seen this from, I'll say, circle detectors looking for nodules in the CAD era, to where we're getting to now, using segmentation, using AI to do very narrow-based focus, to say, hey, is there a stroke in the brain? Is there a nodule or a lesion? Can we circle these different things? But it's still a lot of as a user, taking in these insights and then actually having to do this. And if we want to get to a level of level 5 autonomy when applied to radiology, there's so much more that we have to do that has to happen before we can actually get there. When we think about all the different permutations, I'll talk about that in a second, that radiology has, it's incredible, right? So if I look at, and I just thought about what would level 3 mean, what would level 5 mean. AI is helping us, flagging different, things on an image, handling some of the rudimentary tasks, maybe getting to the point of doing some automatic measurements for me, getting me to the point of automatic protocoling or fetching of priors, drafting, sections of my report, all the way to drafting a structured report. Being able to start to handle things like, we'll just craft what this X-ray report might look like, and you can sign off on that. And leaving some of the more advanced stuff, the CTs, the MRIs, the tomos, to the users. But then going all the way out to what it takes to build a complete automated radiology department. We're still a while before we get to that point. Just a quick digression. I remember when I first started to get into the PACS world, and it was one of my first sims, I think. There were some of these really interesting papers. Who's used AutoHotkey here before? A few people. Yeah, AutoHotkey is pretty incredible. What you can do is basically script how your mouse moves and how things can be typed on the keyboard so that you could automate things that are happening in that space. And when you had a radiologist workstation where you've got your work list, you've got your images, you've got your reporting system, and you needed to take information from one point to another, if your applications didn't allow for that capability, because of lack of APIs or SDKs, or maybe your department doesn't have the latest versions of these things, you could script a lot of this yourself. In this particular paper, this group of users in a hospital were trying to populate problem statements into an EMR and automate this through AutoHotkey to be able to go into the PACS to the reporting engine, strip out some of the key pieces, and then type that automatically into their EMR system. So there are techniques now with HL7 and FHIR that can do some of this, but in absence of having that capability, this is what people would have to do. We're getting to the point now where these things can start to become much more automated. So when we look at radiology and say, just like driving on the streets of Hamilton, all the permutations that we might find, the same thing applies to radiology. There are billions of patients out there. There are tens of thousands of diseases and conditions we might see in medical images. I still always go back to this website that Dr. Chuck Kahn put together with RSNA on, it's called Gamuts, where you could see all the things that you could find in medical imaging and what has caused them, and there's about 12,800 things that they've identified. When we look at patients, they will have chronic care. It might be you're looking at a fracture, but they also have type 2 diabetes. And what does that mean? That the care of patients becomes much more complicated. There are many different modalities, right? Aside from X-rays and CTs and MRIs, but there's also ophthalmology and dental X-rays. There's cone-based CT. There's thermography. There are many different modalities. And there's tens of thousands, if not hundreds of thousands, of different protocols that have been configured at that last mile, let alone the number of vendors who are producing these different modalities. What radiologists themselves, how they use their applications are different. There's, roughly, I used Claude to help me, about 500,000 radiologists in the world. I don't know if that's true, but how they're, working with their PACS, their different versions of PACS, how they stand up their reporting systems, their email, and everything else on their workstations as they go about their day is different. As I said, PACS systems themselves are different, across different vendors, but also across different versions. Same thing with reporting systems. How hospitals and imaging departments are running their business of driving workflows is going to be different. And what the jurisdiction requirements, if you're here in Canada or in Europe or United States or around the world, the requirements for reporting is going to be different. So with all these different things, it's not unlike, I'd say it's worse than what self-driving cars can do. That they have to manage the rain, the sleet, the snow, and everything else on the road. So this is where agentic advancement is going to change the world. It's changing everything that we know about computer science and how we work with our computers. We're just starting to see some of these changes. We're still a ways out, but we're watching it take the world by storm. It started with computer vision, right? So back in the 2010s, you had ImageNet, and you had being able to see things using vision in images, finding stop signs, finding pedestrians, finding stroke, finding cancers. But then we had this breakthrough around, through transformers into large language models. And now all of a sudden, we can take a prompt and do prediction on what that response might look like. And these models are getting bigger and bigger, these foundational models, tens of billions of parameters. It reads all the text of everything. And it uses mathematical functions and probabilities to build up these different responses. As we've seen from this idea of just chat and here's a prompt, here's an answer, we can now start to construct these reasoning frameworks, being able to take a task and identify what are the kinds of things that we need to do in order to accomplish this. There's a talk that I gave at FHIR Dev Days a couple of years ago where I simulated what would it take to build a liver cancer drug program. And I walked through using first with large language models to say, this is what it takes to build an entire drug platform. And it's not execution, but it's just laying out what that would look like and reasoning over to say, is this appropriate? Am I hallucinating? Have I covered all the different aspects, et cetera. Agentic changes that by making it actionable with this idea of tool calling and being able to do a plan and then execute against that plan different tasks. And then where we go from here is this idea of physical AI. That's what's coming next. That's really where we get into robots and really on the execution side. We're at this in the phase of agentic AI and using reasoning and doing actions. A couple of the components that make this possible is being able to perceive, to understand all the different inputs across, not just the text, the tasks that we want to do, but also, leading in on cameras and images and audio, the world around us, what we're actually trying to accomplish. Memory becomes really important. And memory, what I mean by that is it's not just about the task at hand, but also understanding what is it about the patient, all the patient's journey that got them up to this point, being able to leverage that as part of the task that we're going to do. Understanding how does the radiologist or the user work, and all of the preferences and the mechanisms about how they work, in what facility they work at, in what country that they work at, and understanding that as part of creating that execution plan. Looking at all the different tools that we might need to call. I'll talk a little bit about that. That could be calling upon a PACS, calling upon a RISC, calling upon an EMR, calling upon a dictation system, calling upon, if we're still creating reports, and then faxing them to the referring physician. All the different tools we might end up using. And then using reasoning to connect all these things into a cohesive, comprehensive action plan for the task at hand that we want to accomplish. A really neat site to have a look at. So OpenClaw is the latest iteration of, and it's a craze. If you watch what people do some of these OpenClaw conferences, they all wear lobster claws on their head. It's like I'm in Halifax. The idea that we can now orchestrate what's happening and create these skills, these medical skills that we could then stand together to accomplish what we want to accomplish. So this tool's up on GitHub. I don't know the group behind it, but it's 2,200 stars, which is pretty phenomenal for a GitHub repo. It is open source using MIT license, and this is documenting all the different types of medical skills that we might want to take in across the board. So what I've listed here are the ones that they've called out on medical imaging. They've developed skills using PyDICOM, and then a bunch of other things for pathology and neurology and other things. And they're continuing to build on this on a daily basis. If I look at PyDICOM as a skill, PyDICOM, phenomenal library for Python. I teach a course on creating DICOM. PyDICOM is amazing. I can put it in the Jupyter Notebook. I can craft DICOM objects. I create cat DICOM objects that I then store up in a PACS and discover and retrieve. It's pretty awesome. But I can take all the functionality that PyDICOM gives me as a developer and make it really easy for anybody to be able to say, okay, now I want to be able to call upon a PACS that can speak DICOM to be able to retrieve and extract the pixels and then do something meaningful with it. All of the capabilities that that library allows for, we can now put into a scriptable framework that I could just say, hey, go and get this content. Go and extract the metadata. Go and look across an entire set of imaging studies that I might have for a patient or for a disease or for a modality, do research. All of these things I can now take and then connect with all the other skills that have been defined that I could then accomplish into something meaningful. So if I think about taking an AI algorithm, taking a computer vision algorithm, I can now string these things together, but I can do so using my phone and just typing out in a chat interface, this is what I actually want to see. Another example, I don't endorse this, so I want to make that very clear, but it's mind-blowing the kinds of things that people are creating now. It's a scary place. This is a tool called Open Record, again, open up on GitHub. What it can do, if you use Epic, so you have Epic MyChart, as a patient, I can go in and see my lab work. I can go, schedule an appointment. I can converse with my doctor. I can look at all the different things about my records at a particular facility and then connect it to all the other facilities. Open Record allows me to, again, completely script all of this. It can take my password. It can log into my chart. It could go in and create me appointments. I can go in and download my lab results. It can go in and converse with a doctor. And it could do this based on what I would like it to do, but I don't have to use the interface. I can just have a natural conversation and it can go off and do all these different things. It's a scary place because if it can, if a physician is using this on the other side of Epic and be able to sign off on prescriptions or write diagnostic reports for me and click yes, I approve and sign off, we need to really be thinking about the capabilities. But these things are now possible, and the barrier to get there is completely gone. Anybody could take this and script and connect into their records and action things much more than just looking at information. We're seeing agents take the rest of I'll say the healthcare world by storm. So I do a lot of work with ambient scribes. So being able to, if you go in and see your physician, let's just say for a routine appointment, let's talk about your blood pressure, let's talk about your cholesterol. You'll go into the room, the doctor puts their phone on the table, asks you if it's okay if they record, and have that conversation just talking about your care. That phone will capture the conversation, do speech to text, summarize that, highlight the action items, and connect that back into the health record, and use that as something that's actionable to follow up. There's agents that are looking at kind of all that, those stops on the journey. We've had speech to text capabilities for quite some time, but it's about connecting this in building blocks to be able to build out what that experience should look like into the future. The impact to family physicians is phenomenal. There's this idea of pajama charting where you spend 3 hours after your workday charting everything you did with all of your patients for that day. Being able to take that 3 hours of extra time down to about 3 to 4 minutes and just reviewing what actually happened and just saying, yeah, that looks right, off I go. The impact is phenomenal. Patient outreach and follow-up and calling patients. If you think about a program where we have to contact the patients, maybe it's a disease surveillance, maybe it's a disaster in fires or storms or other things, having to call 100,000 patients for clinical reasons is a tremendous amount of work. And if I have to use highly educated, highly trained nursing staff to make phone calls all day, having worked in a hospital where I had nurses sending out faxes and typing things into a computer means they're not seeing the patients. They're not working with the patients. They're not caring for the patients. Being able to automate some of these things so that if we need to talk and connect with the nurse, rather than a nurse, let's dial a phone number and it's a busy signal or they're not at home or whatever it happens to be, we can now streamline that entire operation. And this is done, again, through agents. Being able to connect the bleeding edge of research, whether it's drug research or protocol research or treatment research, be able to connect patients with clinical trials. We could use agents to do the research, what trials are available. Let's look at inclusion, exclusion criteria, not just like, hey, are you between the ages of 50 and 74? But you also have to look at, have you had a particular disease before? Is your hemoglobin between this number and this number? All the different things that make looking at clinical trials matching difficult can now be done through agents who can go and pull this information out, both on the patient side, but also on the clinical trials side, and be able to do that matching at a much faster, much more appropriate level. Standards makes this possible in the world of healthcare. Without standards, all of this would be a lot harder because everything would be much more proprietary. So we can use DICOM to be able to look at images in context of a study. You think about CT exams, a run of images in a series. We need to have standards in order for this to be possible. Otherwise, the amount of effort becomes much more complex and much more expensive. Could it be done? Absolutely. Agents are incredible what they could do because the rest of the world is not as standardized as the world of healthcare. FHIR and HL7 can also help us on the metadata side, but also connect into all the different types of workflows that we might see. IHE helps us because it provides us the recipes for doing workflow in hospital systems. And again, using agents to look at what do we actually want to accomplish. And here's the means that the rest of the world has already adopted. And then barring those things, we have, I'll say proprietary SDKs, frameworks, libraries that help us look at, let's say compressed data, be able to, extract the pixels from there, and even all the way down to supplying credentials, as you saw with the MyChart connector, as well as being able to move the mouse and type things on the keyboard, just like AutoHotkey, but at scale, driven by agentic workflows. how agents could help radiology, right? So, whether it's, summarizing the chart, so we don't have to go looking, needles in haystacks, being able to help us with things like hanging protocols. Having been at, on the PAC side for many years and say, how do I, hang the current and the prior study when I'm bringing in studies from an external entity and I want to match the right, the right series with what I have currently? Or if I'm looking at MRI of the spine and I want to show current and prior over that, maybe, in the 4-up views. Being able to customize and specialize that for all the different permutations was always just chasing knobs and dials, and agents can help us with this. Being able to optimize protocoling, being able to do real-time checks as we acquire images, as we get the images to the radiologist, as we're running AI, narrow AI on that. Use this to help draft sections of reports, entire reports, providing insights at the time. Humans are going to be the ones monitoring and watching what's happening, guiding our agents in accomplishing these tasks. The agents will help us, drive these things, but we're still, as human in a loop, driving. Why are we actually doing these things? Optimize prefetch, things like regulatory monitoring against what my hospital wants me to do, best practices for my department. Being able to, take in things like rounds as we're doing, cancer care, prioritizing, all the different studies that are coming in. Also, enacting upon critical secondary findings we might find, incidentalomas in imaging studies. As I said, it's so important that, this is not taking over the jobs. This is not, it's not going to put people out of work. It's going to change the work that we're doing and allow us to be much more effective, much more intentional, much less cruft, and just being able to drive what ultimately needs to happen for our patients and for our care, our physicians, our nursing staff. We're moving from this idea of doing the work and, let's draw lines on images and measure things to supervising the work. Moving from hunt and peck or find and hunt to being able to drive decisions, being able to bubble up things that are important for us to be able to act upon. We're still in very early days, right? This, changing the paradigm for using computers will take some time. A lot of the work is really geared towards users, which I think is really fascinating. It's less about what our enterprise is doing, but for example, how I work with email is very different than how anyone else might be using email. It is much more personalized experience. Being able to provide the capability as a user, as let's say as a radiologist, how they're using their applications, it is geared towards them as the user, and the agentic calling that we're seeing is much less geared at what does an enterprise do. That will happen. That will take some time, but it will happen. But we're watching this balance kind of unfold, and you'll see think about Don talked a little bit about change management. That top level, we're already seeing some key radiologists just rocking it with what agents can do. We need to be thinking about privacy and data security. A lot of these agents are driven up in clouds. Imagine you just cede control of your computer to a cloud entity that's going to come in and click buttons and sign off on things. It's very dangerous. And so, again, in early days, we're seeing now the capability of sandboxing and being able to drive agents but leave the data in place. So these things are happening. It's so important on the healthcare side, but work is being done in this space. But it's not necessarily quite there yet. If you watch developers using agentic frameworks, agents will come in and say, oh, you need a test plan for this? I'll just delete all of your code and say return true, and your tests work perfectly. It's amazing, but you end up not actually doing anything meaningful. But I've watched developers like my entire code base is gone. That would be really bad if it happened in healthcare. And so applying these workloads becomes really important. The regulatory frameworks still need to catch up. This is happening so quickly. So if I kind of leave you with some next steps, everybody should be thinking about how agents are going to work for them. Whether that's looking at your, your email and how you use computers for the day. All of this is going to change. How this affects your business, how this affects the applications that you're using, your EMRs and your PACS and your risks and your reporting systems, how these worlds come together for you. It's also so important, and this is something that I rail against all the time, having worked in standards and having worked in product management. You need to tell vendors the kinds of things that you want to see. You need to, the more that the workflows can be unlocked so that you can then script agents that can connect to these things is going to be so important. Because, I mean, yes, all these things might be capable, but maybe it's going to be cost prohibitive, maybe it's going to be dangerous. So start working with your vendors, your peers. Even, if you think about in radiology departments, what other radiologists and support staff are doing. Share what you need from agents so that we can build something better together. And just be open and ready, because this future is here. They often say that the future's here, but it's uneven across, across the world, and it's absolutely true. I'm watching some of the thought leaders, what they're able to do and script their interactions, even as you talk to them and email them and converse with them. This is coming for all of us. So be open, be ready. Change management is one of the most important things, but being able to get ready to handle this new paradigm. So with that, thank you so much.